Okay, it's a week of revisions. We are revisiting trig equations. We did a few of them, but I feel like since now we've graphed everything, this is an excellent point for us to really delve into solving them. Okay, so take a look. It says to solve on the interval between 0 and 2 pi. 0 is included, 2 pi is not, and that's because it's one full rotation. So if I start at 0, I fully rotate. I don't want to double up my answer, so we say from 0 to 2 pi. All right, let's do it. Solving for cosine. Right away, I'm going to start isolating because I'm solving for theta. So I'm going to add 1 to both sides. Divide by 2. So the cosine of 2 theta is equal to 1/2. Well, inside 2 theta, that means that I am shrinking my period of the cosine function. We'll deal with that in a second. Solve for 2 theta. So 2 theta is going to be the inverse cosine of 1/2. Okay, so we know that that's at 2 locations. That's the first quadrant and the fourth quadrant. It is pi over 3 in the first quadrant, and it is 5 pi over 3 in the fourth quadrant. And it occurs every rotation. So I'm going to say plus 2 pi k, where k is any integer. Okay, we assume that k is any integer. You don't have to write it at this point. Well, the reason that I'm doing that is because I need to solve for theta, not 2 theta. Okay, I'm going to divide everything by 2. So we're going to say, I'm going to move over here, that theta is equal to pi over 6 plus pi k, and 5 pi over 6 plus pi k. We have to remember that the 2 inside of the parentheses is that horizontal compression. So it's making our graph oscillate faster, which means that where cosine hits the 1/2 value is going to occur faster. So we set up our equations as the normal pi over 3, 5 pi over 3, and then it occurs every rotation. And then we just find our values. Okay, so if the first one's at pi over 6, and then I add pi k, I have to get common denominators, which is 6. So it would occur then at 7 pi over 6, and the next one would be 13 pi over, but that's over pi, 2 pi. Remember, 2 pi is going to be 12 pi over 6, so 13 pi over 6 is too many. So you could write it, and then realize it's too many and cross it out. Okay, so we're done with the first set. We then have 5 pi over 6, and if I add pi over 6, common denominators is 6 pi over 6, we get 11 pi over 6, and I know that that's 1 pi away from 12, so these are my 4 solutions. How do you know when you found all your solutions? If your ratio goes beyond 2 pi, which is the set given restriction. Okay, let's try another one. B. Well, I'm solving for theta, so I'm going to start to isolate. So rad 3 times the tangent of 3 theta is equal to -1. Yes, I see that there's another b value of something other than 2. In this case, it's now 3, so I'll take that into account in a second. So the tangent of 3 theta is equal to -1 over rad 3, but we always take or rationalize, pardon me. So 3 theta is going to equal to the inverse tangent, because I'm solving for whatever theta is, negative rad 3 over 3. I'll make my rad look better. Okay, so where is tangent negative rad 3 over 3? Tangent is negative in the second and the fourth quadrant, separated by 90 degrees. Now you could, if you wanted to, write out 2 separate equations like we did for A. But the nice thing, and let me draw it out for us to see. The nice thing about the quadrant is that for tangent, it's always separated by 90 degrees. So I could write one equation. So tangent of pi over 6 is rad 3 over 3. So if it's negative, that means that it's going to be 5 pi over 6 in that second quadrant, plus pi k. because it'll occur at 5 pi over 6 and then 11 pi over 6. Now, if you're uncomfortable with that, I'm going to go over here. You can say, okay, 5 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. You'll get the same answer. Okay, I just choose to write it as plus pi k because I know that that's the separation. So then if I'm solving for theta, I divide everything by 3. Okay, this means that we are horizontally compressing our tangent function by 1/3. And then it says to solve between 0 and 2 pi. So let's list it out. We're going to say that theta, we know that first value is 5 pi over 18. And then we're going to add pi over 3 because that's how often it occurs. Okay, we need common denominators, which is 18. So 6 pi over 18, which gives us 11 pi over 18. Let's keep adding. 6 pi over 18, we get 17 pi over 18. And right then and there, I'm going to stop because, or should we keep going? Let's try it. Let's try it. Okay, so then if I add another 6, we get, oh, I'm glad we kept going. See, 23 over 18. And then if you add another 6, you get 29 pi over 18. If you add another 6, you get 35 pi over 18, because this is occurring every pi over 3k, right? And we're asked to stay within 0 to 2 pi. If you need to, you can say, since we started at 5 pi over 18, that 36 pi over 18 is equivalent to 2 pi, if you need that as a reminder as you go along. Okay, 35 pi over 18, that's where we need to stop because it's 1 pi away from 36. Okay, if we were to do that for this one, probably should have at the beginning, my bad, for your help, sorry, or for your resource. Our denominator is 6, so we could have put that 12 pi over 6 is equal to 2 pi, so that we know where to stop. Okay, rad, so there's 2, 4, 6 answers. Nice. Let's take a look at this guy. Now, there isn't a horizontal stretch or compression, okay, and there's just a shift to the right pi over 4 units. That doesn't affect the period. So we, yes, need to account for it, but we're not actually going to change anything. So theta minus, like we did in the previous 2 ones, is pi over 4 is equal to the inverse cosine of 1. Well, where is cosine 1? There's just one location within the restrictions we were given from 0 to 2 pi, and that is at 0. So then we need to solve for the theta. So theta is equal to pi over 4. That's it. I know you guys like that one, huh? The only time that we need to do all this fancy stuff with the period is when there is a horizontal stretch or compression. Okay, last but not least, I do like this one. Okay, what does it look like? Yeah, it looks like a quadratic. I'm going to say let x equal cosine of theta. This is called u substitution. We're actually using x instead of u. And we're going to say 2 x squared minus x minus 1. We're allowed to do this because I set x to be cosine of theta. And the reason I did that is so I could easily solve. Okay, what multiplies to -2 and adds to -1, -2, and 1? Those are my factors. So I'm going to say 2x squared minus 2x plus x minus 1. I'm just solving like I would a quadratic. So then I'll factor by grouping. Factor out the GCF. So 2x leaves me with x minus 1, just a 1. You always have to factor something out. And then pull out the factor that's common, group what's left together. Now, when you get to this point, you have to remember that you substituted. So I'm going to put cosine of theta back in. So cosine of theta minus 1 times 2 cosine of theta plus 1 is equal to 0. And now you have 2 equations to solve. Cosine of theta minus 1, just like you would with a quadratic with x, we're going to have different solutions. So cosine of theta is equal to 1. Where is the inverse cosine of theta? 1. And we know that to be at 0. Okay. For the second one, we have 2 cosine theta equal to negative 1. Cosine of theta is equal to negative 1/2. So for theta, where is cosine negative 1/2? Well, we've got 2. It is in the second and the third quadrant. We know that the cosine of pi over 3 is 1/2. So then if I'm in the second quadrant, it's 2 pi over 3. If I'm in the third quadrant, it is 4 pi over 3. So it turns out that we have 3 solutions. Now the reason why we, for this part, didn't have to adjust like we did here is because there isn't a horizontal stretch or compression. There isn't a number with theta on the inside. So we didn't have to account for the period being changed at all. So we'll write our answers together. So theta is equal to 0, 2 pi over 3, and 4 pi over 3. Nice. Okay, now E and F we're not going to do. It includes identities, and we're going to focus on that in a couple of weeks. Okay, so let's just go to solving for a general formula. All right, this is where we're going to use K. And we're not actually, it says to list 6 solutions, so we'll do that, but we really need to focus on being able to state K. Okay, well, first we have to solve. So I'm going to add rad 3 because I'm trying to get cosine of theta by itself, and then divide. So cosine of theta is equal to rad 3 over 2. We're solving for theta, so we're going to take the inverse, cosine inverse of rad 3 over 2. Remember, ASTC. Okay, cosine is positive in the first and the fourth quadrant. So we're going to say, and there isn't an even separation, so yeah, A and C are separated by, we could say approximately 270, but then C to A, fourth quadrant to first quadrant, is only 90. You can't write it as one equation like we did for tangent. So we're going to say that this is pi over 6 plus 2 pi k, and then 11 pi over 6 plus 2 pi k, where k is any integer. You can write out is any integer. You can do the fancy symbols. That just means k is any integer. Okay, nice. Okay, then it says list 6 solutions. All right, so theta would be pi over 6. And then if I add 2 pi, that would be 13 pi over 6. Because remember, 2 pi with the denominator of 6 is 12 pi over 6. Don't be afraid to write this stuff out, you guys. Okay, if you can do it in your head, great. If you can write it out because you have to, great. Okay, it doesn't matter. Do what's easiest for you. And then that's 25 pi over 6. And then additional, if we do the 11 pi over 6 plus 12 pi over 6 is 23 pi over 6. And then 35 pi over 6. And those are 6 possible solutions that we have in our solution set. Nice. Okay, sine of 2 theta. Okay, so yes, you notice right away there's a b value. So we're going to say that 2 theta is equal to the inverse sine of 1. Now this is going to be a little bit different because 2 does affect the period. It's going to compress it by 1/2. But we're not trying to find solutions within a specific range. So we'll write it out, but we're not going to have to go through and list all of the values and then cancel out the ones that are beyond our x or domain values. Okay, so 2 theta, where is inverse sine 1 at pi over 2. And then theta, oops, just kidding, I'm getting ahead of myself. Okay, and this occurs every 2 pi k radians. So then we're going to say that theta is pi over 4, and this occurs every pi k because we have to divide both values by 2 in order to solve for theta, where k is any integer. Nice. But it says list 6 solutions. So, okay, pi over 4, and then if we add pi, That's 4 pi over 4, so this is 5 pi over 4, and then 9 pi over 4. And hey, let's get fancy. Let's go negative. So if we have pi over 4 plus pi times a negative 1, that's pi over 4 minus 4 pi over 4. So negative 3 pi over 4. And then negative 7 pi over 4 and negative 11 pi over 4. So there's 6 solutions for our solution set. Cool. All right, last but not least, tangent. And this doesn't have a restriction either. We're just trying to solve for all solutions. All solutions. Okay, so theta over 2 is equal to the inverse tangent of 1. Yes. Parentheses, no parentheses, I just like it better. Yes, we are increasing the period. We're stretching it by 2. But first, let's solve. So theta over 2 is equal to pi over 4 plus the period. I wonder if any of you caught on to that, huh? Plus the period k. Okay, and then we multiply everything by 2, so theta is going to be pi over 2 plus 2 pi k. Nice. And list 6 solutions. So theta is equal to pi over 2, and then plus 2 pi, so that's 4 pi over 2, so 5 pi over 2, and 9 pi over 2. Yeah, let's go negative again. So pi over 2 minus 4 pi over 2 is negative 3 pi over 2, negative 7 pi over 2, and negative 11 pi over 2. And there's our 6 possible solutions. Now your 6 solutions may vary depending on what you chose, what direction you chose to go, and that's fine. So remember when we're listing out the pi k or the 2 pi k, yeah, guys, it is the period. Just like when we were graphing and we were stating domain and range, right? And then when there were asymptotes, it has to do with the period. The period of cosine is 2 pi, and then we divided it by 2 because b was 1/2. The tangent period is pi, and then we divided it by 3 because b was 1/3. Okay, it's all items that we know. Using our unit circle, using our graph, you're good to go.